Hello everyone, my name is Devashish Roy. I'm the Senior Network Analyst at the Indian Cybersecurity Solutions, and I welcome you all to this special webinar. And today's topic is a very interesting one, that is multicast routing. We'll be talking about what is multicast, why is it different from the unicast or broadcast, and what is PIM, Protocol Independent Module, and IGMP, Internet Group Management Protocol. These are two protocols that is very vital in the Cisco environment for multicast. So let's begin. So we'll be discussing the multicast. The multicast routing. What is a multicast? Multicast means one to many or one to a group. So you know that there is unicast, one to one, broadcast, many to many, and multicast, one to many. It enables the efficient transmission of data to multiple recipients at once and reducing bandwidth consumption and improving the overall network performance. So it is like we are streaming a video, like this multicast is going on, this webinar is going on, this live is going on. So that is a multicast. We can stream some video data, like we can use some, say, real player or VLC media player to generate the multicast stream. Now PIM, protocol independent multicast, and IGMP, internet group management protocol, these protocols play a crucial role in managing multicast group memberships. So we generally talk about the IGMP, that is between the host and the router. If you're going to say, host is going to send a report message, router is going to send the join message, it is actually inviting the host to join, and the host is sending report message, but PIM is also there between the routers. You have to understand the multicast routing. Multicast routing enables efficient transmission of a single data stream to multiple recipients simultaneously. So it is not like it is going to everyone, no, but it is going to a specific group of devices. Group addressing for receivers means by utilizing specific group addresses, multicast routing identifies and targets multiple receivers without the need for individual addressing. So, like some protocols like OSPF, it has 224.0.0.5 and 224.0.0.6, that is the multicast address. Like you can say in case of, let's say, some other protocols, like if I talk about the RIP, routing information protocol, there also we see multicast 224.0.0.9, that is the address. In case of EIGRP, 224.0.0.10. So these routing updates are sent to the specific addresses, not individually, means not in an unicast one-to-one way. Bandwidth efficiency compared to unicast means multicast routing is more bandwidth efficient compared to unicast, because unicast means one-to-one communication utilizing bandwidth one-to-one. But here you are sending to a group. So what you are doing, you are actually sending to multiple recipients. So at once your data is being delivered. Like you are sending, let's say, a mail to a group. So your bandwidth consumption is less, and it is optimal use of available bandwidth resources in your network. Now let's come to what is the importance of multicast in networking. So it reduces network traffic definitely, because one-to-one means each individual stream is going on. So it is definitely a resource intensive, saves bandwidth, that is the second point, and enables real-time applications, like I've already told you about the real-time or this, let's say, the VLC player. These things, it can be used to generate the multicast streams. Now let's come to the overview of the PIM, protocol independent multicast. PIM is a multicast routing protocol designed to actually facilitate the efficient delivery of multicast traffic across networks, and it functions independently from unicast routing protocol. Let's say you are using routing protocol like OSPF, IGRP, BGP. Some protocols use multicast, some are unicast, but it is independent of those. And it functions independently from routing protocols, allowing it to adapt to different network architectures and requirements, enhancing the flexibility and scalability of the organization. There are two modes in case of PIM: PIM sparse mode and dense mode. So let me tell you what is the difference. In dense mode, what happens, that it is like the broadcast that is happening. So if a node is not going to participate in the multicast, say I'm the node, I'm not going to join the multicast stream, even then also the source, the multicast stream broadcasts the stream to every other node, and the every other node is forced to join that multicast group. That is a dense mode. It creates a lot of traffic, so it is not good. So sparse mode means individually it can have the join request, like, say, let's say the receivers, they can report the message, they can actually send the report message to the source. So specifically it's designed for environments where multicast receivers were sparsely distributed across a network. It utilizes a shared tree structure. But in case of dense mode, it is actually multicast receivers are present throughout the network, and it initially floods or broadcasts multicast traffic to all network segments. So sparse mode is better, not the dense mode. But you can actually implement one of the modes in the multicast. So we'll be only configuring the basic multicast here in the GN3, and here you can implement either sparse mode or dense mode, it doesn't matter. So PIM operation, it uses a rendezvous point, that is RP, and PIM employs a rendezvous point to facilitate efficient multicast group management. So what is a rendezvous point? Like your join request is going to the rendezvous point, the RP. It is not going directly to the, say, the source, the server. The RP acts as a central point for multicast source and receivers to join and leave multicast group that I was talking about. So it is like it is managing all the multicast activities. Now, source specific and shared trees. There are two trees. Now, PIM supports two primary mechanisms for multicast routing. One is the source specific trees, or the SPT, and shared tree. SPT is used for direct communication from a source to receiver. So if you are going to send, let's say, a multicast traffic, and the receiver is going to receive it, so SPT is used for direct communication. And while shared trees allow multiple sources to send data to a group through a common RP, rendezvous point. So when you are talking about RP, definitely that is shared tree. So there are many, say, distribution points. There are many receivers. So you are actually sharing the tree. You are actually sending the data across the tree. But in case of the SPT, like we have a SPT switchover also in case of the, say, the dense pass mode. So what happens at first, it actually uses a shared tree, and then it actually uses a more optimized part that we call it the SPT switchover. That is a different issue, but we can have these two trees in the multicast routing. Now, let's talk about the join and prune mechanism of the messages. PIM employs join and prune messages as part of its operation. So, join messages are used by routers to signal the intention to join a multicast group. So, they actually, routers, they send a join message. Like the receivers also want to join the group. Well, while prune messages are sent to withdraw from a group or to leave a group. Say you want to leave a group, you want to send a prune message to that. And it ensures that only active participants receive the multicast traffic, not others. Then the IGMP, Internet Group Management Protocol, let's understand a bit. IGMP also is the same thing, but it enables hosts to communicate their desire to join or leave multicast group. Now, PIM is used between the routers, and IGMP is used between the source and that is the host to the router. Like host want to join or leave the group, that it depends. IGMP plays a crucial role in optimizing multicast routing within IP networks. There are three versions. Let's discuss IGMP version 1, version 2, version 3. Version 1 basic membership management provides a fundamental mechanism for multicast group membership. However, it lacks the functionality to send leave message. Yes, it's very important. In version 1, you can only join. But if you want to leave the group, multicast group, can you do it? No. Which means that host cannot inform the network when they want to leave a multicast group. It is inefficient. So you want to only join, but you cannot leave. So definitely the multicast traffic will increase. You do not need to be part of a group. Still, you are forced to be part. It is not an efficient one. IGMP version 2, it has improved efficiency with leave messages. Yes, IGMP v2 builds on the foundation of IGMP version 1, and it introduces the leave message. The prune message. This allows hosts to notify the network when they want to leave a multicast group, and it improves the overall multicast efficiency and reduces the unnecessary traffic. So if I do not want to join, let's stop that multicast stream. I do not want to receive that. That is the simplest thing. IGMP version 3, what is the difference? It is almost like the IGMP v2, but source specific multicast support. What does it mean? SSM, source specific multicast, means it allows us to specify from which source they wish to receive traffic from. See, there can be n number of sources. In case of version 1 and version 2, you cannot specify the source that I intend to receive traffic from. But in case of v3, it is possible. So that is the only difference between v2 and v3. Otherwise, it's same. And you have to configure the PIM and the IGMP, like enable PIM on interfaces, activate the PIM. I will just show in a while. In the GNS3, we'll implement IGMP. Configure the rendezvous point for PIM SM for the SPD switchover. But for the basic configuration that we'll do today, there will be no rendezvous point. We'll do only the multicast routing. We'll configure the simple IGMP PIM there, and we'll check the IGMP interfaces, whether it's enabled for multicast routing. This thing. Activate the interface, configure the RP for PIM, the protocol in module, and the SM, and verify PM configuration with the proper debug command. And configure IGMP is almost like same. Enable IGMP snooping to optimize multicast traffic. Now you can do it with IGMP snooping if you want. That definitely the switches will optimize the multicast traffic handling. But if you do not, you can also disable the IGMP snooping. That is your choice. Configure IGMP version. You can do it. That is also optional. Set the appropriate IGMP version on interfaces. If you do not configure it is IGMP, say version 1 by default. And monitor IGMP groups. You have to regularly check the IGMP groups and membership to maintain the network integrity and performance. And you have to also troubleshoot the multicast routing, check PIM neighbor relationship with PIM neighbors, verify IGMP group membership with IGMP membership command, use debug commands for real-time analysis for traffic. So use case of multicast is video streaming. I've already told you, online gaming, and financial data distribution. So this type of online transaction and online video streaming, this multicast is used. Modern networks enabling applications that require real-time data delivery applications. So this is about the, you can say, a brief theoretical discussion on the multicast routing PIM IGMP we have. And now I will take you to the more practical approach. This is the Genesis console. So let's begin. I will just send some ping packets. Or ping 3911, and only this but if you say repeat second or we're not in it. Should not say IP. Because routing here it is other check this. So I think IP is not valid. It is